minus 3. Okay, and then we went into verification of your Cayley-Hamilton theorem. Then after doing your Cayley-Hamilton theorem, we went into eigenvalues and eigenvectors. In your eigenvalues and in your eigenvectors, how do you do it? Eigenvalues, the characteristic equation which you've got, isn't it? That you have to solve that equation. Okay, solve that equation. How do you solve it? You will substitute the values for lambda and see with what value if you put, you get it equal to 0. Get that value, do it is using your synthetic division, get your eigenvalues. After getting your eigenvalues, get your eigenvectors. Okay, so for the corresponding eigenvalues, you'll get the eigenvectors. Then we went into the properties of your eigenvalues. So in your properties of your eigenvalues, the sum of the eigenvalues is equal to the sum of the main diagonal elements. Did you check it out for all the problems which you have already done? If no, do it today. Okay. So check whether your sum of your eigenvalues is equal to the sum of the diagonal elements, main diagonal elements. And product of the eigenvalues is equal to determinant of A. So that is one of the main important property. Then we went into finding out your lambda, when it is for lambda values for your matrix A, then for A transpose also the eigenvalues will be the same. Okay. And then for triangular matrix we went for a triangular matrix, so that if it is an upper triangular matrix or a lower triangular matrix, you will take the eigenvalues to be the diagonal elements. Okay, so till here we have finished. We will continue. So put today's date. Today is 11. Put today's date and start writing the property. So the next property is if lambda is an eigenvalue. Lambda is an value of a matrix A, then 1 by lambda, where lambda is not equal to 0, is the eigenvalue of A inverse. Okay, if lambda is the eigenvalue of a matrix A, then if they're asking you to find the A inverse, eigenvalue of A inverse, then whatever lambda values you've got, you'll take it as 1 by lambda. Okay, so this is one of the property. So write, for this I will give you one problem. Two of the eigenvalues of A is equal to, I'm writing a 3 cross 3 matrix, 3 minus 1, 1, minus 1, 5, minus 1, 1 minus 1, 3, are 3 and 6. Are 3 and 6. Okay. Find the eigenvalues of A inverse. Find the eigenvalues of A inverse. Okay. So this is the problem. They have given you 2 eigenvalues. So since they have given you 2 eigenvalues, you can find the third eigenvalue. How do you find out? One, you can do it with the sum of your eigenvalues equal to sum of the main diagonal elements. Two, you can do it by like product of the eigenvalues is equal to determinant of A. I will do it with the sum of the eigenvalues equal to the sum of the main diagonal elements. So in the problem, since they have already given A, they have denoted the matrix, you need not denote it here. Okay, so you can denote your eigenvalues. So denote your eigenvalues. Let lambda 1, lambda 2, lambda 3 be the eigenvalues of A. Be the eigenvalues of the given matrix A. Okay, and they have given your lambda 1 is equal to 3, lambda 2 is equal to 6. You don't know what is your lambda 3. Okay, So we are using your first property. That property is sum of the main diagonal elements. That is sum of the sum of the eigenvalues is equal to sum of the main diagonal elements. So that will be 3 plus 5 plus 3. So that is equal to 8, 11. Okay. And you know what is your value of lambda 1 and lambda 2. So that is 9 plus lambda 3 equal to 11. So from here, lambda 3 is equal to, okay, so your lambda 3 is equal to 2. So your eigenvalues now for A will be the lambda values for A. Okay, your eigenvalue, or you can write it. Your eigenvalues of A is equal to what are 3, 6, and 2. Okay, so that will be the eigenvalues for the given matrix A. But here they have asked you find out the eigenvalues of A inverse. Okay, by this property, for this eigenvalue where for A inverse, it will become 1 by lambda. So therefore, what will be the eigenvalue for A inverse? The eigenvalue of A inverse will be 1 by 3, 1 by 6, and 1 by 2. Okay, so with that property, you can write this. Write it down. So this is how you're going to find out your eigenvalue for A inverse. The same way you can do it with product also. Okay. With the same data, you can do if you are very well thorough with your determinant of A. That is how to find out your determinant A. If you are able to do it very fast in that, then you can take your product of the eigenvalues equal to determinant of A. And then you can find out your third eigenvalue. After finding out your eigenvalue, find out your eigenvalues of A, which is nothing but 1 by lambda. Finish writing? So I have next property. If lambda 1, lambda 2 up to lambda n are the eigenvalues of a matrix A. If lambda 1, lambda 2, lambda n are the eigenvalues of matrix A, then A power m as the eigenvalues, A power n as the eigenvalues, lambda 1 power m, lambda 2 power n, so on up to lambda n power n. Okay, this is the next property. It is nothing but whatever eigenvalue you're getting for the matrix A, if they're asking you find out the eigenvalues of A power 4. Okay, if they're asking it like that, what you have to do is you will put it in whatever eigenvalue you're getting, power that. Okay, so whatever power you've got, that power you will write it there and you find out your eigenvalue. Okay, so this is another property. So that property, if you imply here also for A inverse, your A inverse, it is nothing but you will put it power 1. So your power 1, if you put, that will become 1 by 3. Okay. So there, if the lambda 1 up to lambda n are the eigenvalues of the given matrix, and if they're asking you to find any power Okay, any power of your eigenvalue, it is nothing but it will be whatever lambda you're getting, whatever power you will get. Okay, that will become the eigenvalue. Find the eigenvalues. Find the eigenvalues of a cube. Okay. There was a cube given. They have given a matrix 1, 2, 3, 0, 2, minus 7, 0, 0, 3. Okay. Now first, okay, write it down. First see what matrix is this. Tell me what matrix is. This is a upper triangular matrix. Okay, this is an upper triangular matrix. Since it is an upper triangular matrix, you can directly write it from the question itself. What is your eigenvalues? So, since it is a, you'll write it. It is an upper triangular matrix. It is an or the given matrix. A is a upper triangular matrix. Since it is a upper triangular matrix, you can write the eigenvalues directly. What are the eigenvalues? The eigenvalues of A. What will be the eigenvalues of A? You'll be using the property when it is a triangular matrix, your eigenvalues will become the diagonal elements. Okay, so your eigenvalues are 1, 2, and 3. Okay, so according to this property, when you're going to find out any powers, okay, we are finding out the eigenvalues of some powers, what does it imply? You will write it as eigenvalue of A cube is equal to, it will be 1 cube, 2 cube, 3 cube. Okay, which is nothing but 1, 8, 27. So your eigenvalue of A cube will be 1, 8, and 27. This is how you're going to find out your. So these are your properties. Properties of. If you've got any doubt. Whoever's unmuting, if you're really having any doubts, please unmute. Okay. So with this, we will finish off with your property. If you've got any doubts? Next, we will go on to orthogonal matrices. This is also very important. First, we will write the definition. Then we will go on to problems. Orthogonal matrices. A square matrix is said to be orthogonal. Is said to be orthogonal. Anyone knows how it is orthogonal? If how it is orthogonal. A square matrix is said to be orthogonal if your A transpose is equal to A transpose A is equal to your identity. If it is becoming your identity matrix, then the given whatever given matrix will become orthogonal. Okay, the given matrix is orthogonal. Not transpose. A complement is transpose. Write this problem. Show that given matrix A is equal to cos theta, sin theta, minus sin theta, and cos theta. So they've given a matrix is orthogonal. You have to show that the given matrix is orthogonal. So what you'll have to show is you'll find out your A inverse or your A complement and see whether it is equal to your identity matrix. Okay, if it is equal to your identity matrix, then it is orthogonal. So first write down what is your A inverse, A complement. So we will go on to the problem. So this is your question. So your A complements will be cos theta. You will take a row column. Your row will be cos theta sin theta. And then your row minus sin theta cos theta. After that, you take any one. Okay, you take A complement, or you can take A complement A. Anything. Okay, any one you can take and see whether it is equal to identity matrix. So we will do it here. Okay, so we will do A complement. So that is equal to your A matrix is cos theta sin theta minus sin theta cos theta into your A complement is cos theta minus sin theta and sin theta cos theta. Now you multiply, okay, row into column. So that will become cos square theta plus sin square theta. Finally, it will be minus cos theta sin theta. You're doing first row and second column. Okay, cos theta sin theta, and then it will be plus cos theta sin theta. Okay. Similarly, here the second row and first column it is minus sin theta cos theta, then cos theta plus cos theta sin theta. Second row, second column, minus into minus plus it becomes sin square theta and plus cos square theta. Okay, so these two terms gets cancelled. Here also it gets cancelled. You know cos square theta plus sin square theta is equal to 1. Okay, that's the formula. So it will become 1, 0, 0, 1, which is your identity. So the given matrix is orthogonal. Therefore, A is You finished? There are a lot of problem in your orthogonal. One more I will do. This you can do it as well. They have given you, show that the matrix, 1 by 3, and then they have given the matrix 2, 2, 1, minus 2, 1, 2, 1, minus 2, 1, minus 2, 2 is orthogonal. Okay. You have to show that this matrix is orthogonal. Okay. Try out. So when it is orthogonal, to prove that it is orthogonal, we will take your A complement is equal to, you have to prove that it is an identity matrix. Now, since they are not denoted with any matrix, that is any symbol, you will denote it first. Okay. So since they have taken this 1 by 3 outside, you also keep that 1 by 3 outside itself. Don't multiply it inside, because if you multiply it inside, it will little be complicated. So instead, you keep that 1 by 3 outside itself and multiply it in the last. Okay. So first write your let A is equal to 1 by 3, your given matrix. Since we have not denoted, we will denote it first. Okay. And when you're writing the numbers, be very careful. Don't go wrong in writing the numbers. Okay. And your A inverse will be, your 1 by 3 will be the same. Here alone it will be 2, 2, 1, minus 2, 1, 2, 1, minus 2, 2. Okay. Now multiply it. We will do this A complement. So that will be, I am taking this 1 by 3 common outside. So it will become 1 by 9. Okay. So into 2, 2, 1, minus 2, 1, 2, 1, minus 2, 2. And here it will be 2, minus 2, 1, 2, 1, minus 2, 1, 2. Multiply. Multiply and see what you get. Have 4 plus 4 plus 1, minus 4 plus 2 plus 2, 2 minus 4 plus 2. Second row, first column, minus 4 plus 2 plus 2, 4 plus 1 plus 4, minus 2 plus 4, 2 minus 4 plus 2, minus 2 plus 4, 1 plus 4 plus 4. Okay. So when you multiply, so what you get? You'll be having 1 by 9. When you add, you have 9. Here it becomes 0, 0, 0, 9, 0, 0. So when you divide it by 1 by 9, when you take it inside, okay, you get 1, 0, 0, 0, 1, 0, 0, 0, which is your identity. So since it is becoming an identity matrix, it is an orthogonal. The given matrix is an orthogonal matrix. You will conclude it. As homework, what you will do, I will tell you. Instead, you are able to see. As homework, you will do, show that A is equal to 1 by root 2 minus 1 by root 2, 1 by root 2, 1 by root 2. This is the given matrix. You will have to see whether this is orthogonal. Let's check this problem. And another problem is also there. Yeah. Have you all finished writing? I will write it here. This is your homework problem. One homework problem, another homework problem. If A is equal to this, that is 1 by root 3, 1 by 6 minus 1 by root 2. 1 by root 3 minus 2 by root 6, 0. 1 by root 3, 1 by root 6, 1 by root 2. This also you will prove whether it is equal to orthogonal, whether it is an orthogonal. 1 by root 3, 1 by root 6 minus 1 by root 2. By root 3 minus 2 by root 6, 0. 1 by root 3, 1 by root 6, 1 by root 2. Okay. So you will find out these two problems. You will see whether it is orthogonal. Okay.